So our video today is a review of our properties of functions. And a lot of this is going to be review from Sec 3 and Sec 4. So I've tried to write it so that you can write it down as notes, but you probably already have a lot of these notes from previous years. So it's going to be quite a note-heavy video, but depending on what you have from previous years, you may already have a lot of these things down. So when we have a connection between two variables, we call that a relation. Okay, so some kind of connection between an x and a y, or whatever two variables we have, we call that a relation. If one variable causes a change in the other, we call that variable our independent variable. Usually that's our x. So our independent variable is x, and it changes and causes a change in our dependent variable. So the variable that changes in reaction is a dependent variable, and it makes sense. Independent can change on its own, and it causes some kind of change. Okay, so y will change depending on x. So for example, if we have frozen turkeys being priced by their mass, so they're sold by how heavy they are, the independent variable is the mass of the turkey. Okay, and depending on the mass, our price of our turkey will change. So our dependent variable is that cost, the price of our turkey. An inverse relation, or the inverse of a relation, or just the inverse, is found by switching variables in our ordered pair. Ordered pair meaning an x and a y together to have a point. So for example, if we have relation A and relation B, what you'll notice here is that they are inverse. Okay? So relation B is the inverse of relation A. And we can tell by looking at our points here. So we see our first point here is 0 and 3. So x is 0, y is 3. But for relation B, x is 3, y is 0. And that's consistent for all of the points that we have. And what we notice about our graph is we see a symmetry. So we'll see that there has been a kind of flip across this y equals x line here. Okay, so all of the points are opposite to each other. A function is a special kind of relation where there's only one y value for each x value. Okay? So only one dependent variable for each independent variable. So if we look on the left here, it says it's a function. And you probably remember from Sec 3, we would do something called the vertical line test. Okay, so to test if something is a function or not, we do a vertical line test. And if at any point in time, when we draw a vertical line, we go through more than one point, some of my lines are not so vertical. In theory, vertical line test, if we go through more than one point, then it's not a function. So if we look at our second relation here, our second graph, we can see that when we draw a vertical line right there, we actually end up going through 2 points. So this guy fails that vertical line test. It's not a function. There's 2 y values for that one x value. Continuing our study of properties of functions, some more terminology that we need to remember from Sec 3 and Sec 4. The domain is the set of values of the independent variable. Okay, so when I ask you what the domain is, what I'm really asking you is, what are the set of numbers that work for x? Okay, the range is a set of values of the dependent variable. So what are the values of y? Our functions can also have the property of being increasing, decreasing, and constant. The definition of increasing is that as x becomes bigger, y becomes bigger. Or as x becomes more negative, y becomes more negative. So they're changing in the same way all the time. So if I'm looking at this graph here, this section right here is increasing. So as x is increasing, y is also increasing in response. Decreasing means the opposite. So as x increases, y decreases. Okay? So we have an opposite situation, whereas x decreases, y increases. This part of our graph right here is decreasing. So as x is increasing in value, as x is getting bigger, my y value is getting lower and lower, smaller and smaller. And we can also have functions that are constant, and a lot of you guys remember that from previous years. A constant function means that no matter what my x is, my y is always a constant value. So this section of my graph right here is constant, okay? So as my x changes, my y remains a constant value. When we have a graph or a function, we can also have, or not just a graph, a table of values, or any other way that we describe a function, we can have a maximum and a minimum value. So a maximum value is the largest value of the dependent variable, so your biggest y value, and your minimum value is your smallest y value. And if we were to look at this graph here, my maximum is going to be here. Oops, I picked up the blue pen. I forgot that one doesn't work. My maximum is going to be here. Okay, it has the largest value of my dependent variable. And my minimum is going to be down here. So up here will be my maximum value. And down here will be my minimum value. Our functions can also have a sign. So over any given interval, if a function is positive, if y is positive. So if our dependent variable y is positive. It's negative if the dependent variable is negative. Okay? So let's take a look at that graph again. This is kind of a bad example because actually the entire graph is positive. It only includes positive y values. What would we have to do to have a section of our graph that is negative? If that line was extended down, that green section would be negative because my dependent values would be negative. And this is something we've actually already been working with a little bit this year. Our intercept values are basically where our function crosses the x and the y axis. So our zero of a function is also called the x-intercept, and it's the value of the independent variable when the dependent is 0. Our initial value is also called the y-intercept, is the value of the dependent variable when the independent is 0. And remember that dependent means y, independent means x, so if you're writing notes from this, that's what you want to write down. And let's take a look at this here. And I'll do this in red. So what is the 0 of my function? It's going to be right there. Okay, that's where my y value is 0. So my 0 of my function is going to be 13 because that's where my function crosses the x-axis. What is my y-intercept or my initial value? It's over here. Okay, so the y-intercept or the initial value, maybe I should be consistent here. The initial value is 2. Okay, so that is the value on the y-axis, that y-intercept.